how do we solve, they're asking us, this is number 1, so I'm in 2.6, question number 1. Express the distance from P to the origin as a function of x. And they're giving me this P is some point x, y on the graph y equals x squared minus 3. All right, well, that sounds kind of weird. So there's only 6 questions in this section. They're all going to be somewhat similar. Let me give you the game plan. What I'm going to do right now, you don't really have to do. So you don't have to draw a graph, and I'm going to draw a graph and do some stuff. It's just to help you. Not required. I'll show you what you actually need to crank through. But I want to make sense of it for you before just saying step 1, step 2, step 3, boom, there's your answer. Here's why those steps are going to really be true. What they're talking about is they're talking about a graph. Y equals x squared minus 3. You guys are becoming good graphers now, right? Your graphing ability is getting strong. So you can just look at y equals x squared minus 3 and know what that generally looks like, right? What does that thing look like? It's a U-shape. Yeah, x squared is a U-shape. What we call it officially. Where is the thing? What is that minus 3 going to do? Is it left 3, right 3, up 3, down 3? What is it?
Lower 3.
All right, maybe we better talk about it. So if we had that, if it was in the parentheses, it's not. If it was in the parentheses, it would be a right-left kind of thing. Right? Because in the parentheses is an x kind of thing. You're in x's little world. So you're right-left. So that and it's opposite. So that would be left, no, opposite. That would be right 3, wouldn't it? It's not what we have. If you had x plus 3 squared, that would be left 3, because opposite. But when you have the minus 3 outside, that's down 3. And if you had a plus 3 outside, that would be up 3. Because when it's outside of the parentheses, it's a y thing. It's an up-down thing. It's not in x's little world. So the one we have, x squared minus 3, is a down 3, isn't it? Going down 3, right there. So it's a U-shape down 3. So that's generally what the graph looks like. Okay, so now, what are we supposed to find? Well, notice there's 3 parts remaining down here. There's a bunch of parts. What they're going to basically do, let me just tell you what they're leading to, where they're going. They're going to basically end up saying, look, here's the origin. And if you're a little person cruising on, I'll say this is a roller coaster or whatever, little roller coaster ride on the y equals x squared minus 3 graph. If you're on a roller coaster ride, when along that curve, along that ride, are you closest to the origin? That's where they're going. Eventually, they want us to find which single location on that U-shape is closest to the origin. How are you going to... I'm guessing it's somewhere right around here. I probably didn't draw my graph very well. But somewhere right around here, I think is right. It's closer. This is 3 away from the origin, right? Straight down is 3 away from the origin. I think if you get over here, you're a little closer. Here, looks like you're further away. You're 4 or 5 away. At some point around this, and there's the same point on the other side. There's actually 2 points that are the same distance from the origin, aren't they? I'm guessing they're sort of in that vicinity. And it turns out that is right. They're going to be in that vicinity. We'll get to particulars in a second, and I'll show you the steps. But you getting the big idea? We're supposed to find the 2 locations that are closest to the origin. All right, now how do you go? That's what they're leading us to. So let's go about the business now. You don't really need to draw a graph and do all that stuff. So let's go to finding it. So, okay, so here's what you have to actually do. First off, you got to write the distance. You guys remember the distance formula from your algebra days? Anybody? It's the square root of x1 minus x2 squared plus y1 minus y2 squared. Good thing to put on 3x5 card, but I say that about everything, don't I? Put that on your 3x5 card, along with everything else, but leave plenty of room. Just kidding. All right, so that's the distance formula. Do you know where that comes from, guys? Well, the slope comes from rise over run. Say you have a couple of points, and this is the point x1, y1, and this is the point x2, y. Again, I'm doing stuff not required, so bear with me for a minute. I just don't like to give formulas without reasons. That's not very interesting to me. So I want to be more helpful to you to show where this stuff comes from. Say you want to find the distance, from the x1, y1 point to the x2, y2 point. How could you find the distance from one of those to the other? Well, you could make a right triangle out of it, huh? And then we're going to do the Pythagorean, basically. Yeah, what's the distance from along here? What's the width of that? Well, it's x2 minus x1. It's this x position. This one's at over x2. This one's at over x1. So this width here is x2 minus x1, right? The difference of x values is the width. What's the height here? What's the difference of y values? It's going to be y2 minus y1. It's this one's height minus that one's height, right? This point's height minus that point's height. So anyway, this side is x2 minus x1. This side's the difference of y values. So using the Pythagorean theorem, this squared plus that squared is distance squared. So distance squared is x2 minus x1 squared plus y2 minus y1 squared. So how do you find distance? Root it, distance equals that. That's where we get the distance formula, just like that. Now, you might go, wait a minute, Aaron, this is x1 minus x2, and this is x2 minus x1. And the y's are reversed also. Doesn't matter, does it? How do I know? How can I look at that? I hope you'll increasingly be able to look at that and say that. Why? How do you know? Slope formula, it matters. Here it doesn't. Why? How do I know? Not by memorization. Math and science is not by stuffing your head full of all these little facts that so I never would have made. I have a terrible memory. It's about logic. Why logically does that order not matter?
You can't have negative distance, so if it's negative, if you end up with a negative in the...
No, I think you're thinking too deep. I'm not talking about the whole root and all that. I'm just simply saying x1 minus x2 squared is not different than reversing the order. That is for sure the same thing.
It doesn't matter if it's negative, it's going to end up being the same because you're squaring.
Yeah. Whenever you're looking at something like that, say you're looking at something, say, can I switch the order? Are those really the same? You know what's good to do, guys? Is just put in numbers. I learned so much when, I remember I was in Algebra 2 back in my high school days a long time ago. My little friend Mike Bell, and he was getting an A, and I wasn't getting an A. And I remember I asked him some rule about algebra, and he said, well, just plug in numbers. And I was like, oh, that's why that guy's getting an A. Just plug in numbers. Just say, is 5 minus 3 squared any different than 3 minus 5 squared? That's what I'm basically asking. And we think so much better with numbers, right? Isn't that what I'm asking? Can you switch the order, subtract it, squared? Well, of course that's the same, because this is 2 squared, and this is minus 2 squared. In the end, it's 4 either way. Because it's squared. It's going to bury the sign, make it all positive. So that's why it doesn't matter. It's just as simple as that. All right, so there we have the distance formula. I messed this one up. I need another page. So let's use it now. So the distance formula then is the square root of... Now, what are my 2 points? I did my 2 points. Origin. So what's the origin? 0, 0. And the other point, they just want you to use a general xy. Just call it xy, because we don't know what it is. It's just some other point, xy. So your 2 points, your x2, x1, your 2 points are 0, 0, and xy. So then just go 0 minus x squared plus 0 minus y squared. Make sense? I just did the 2 x values and the 2 y values. So then the distance formula is square root of x squared plus y. The zeros just vanish, huh? 0 doesn't do anything, and the negative x squared is regular x squared. Negative y squared is regular y squared. Good to there? Now, they're going to ask us to use our graphing calculator to graph that and find the minimum distance. That's what it means to be closest. Closest means minimum distance, doesn't it?
Wait, but when it says original, do we put 0, 0, or do we put the origin of where it's moving?
They're saying, what is the distance from the origin? It's not original, it's origin. From the 0, 0 origin.
Oh, it's not
from
it's
P
not from its new
to the
location,
origin.
where it's 0, 3, or 0, negative 3.
So we're just saying some point on the graph, call it xy, to the origin 0, 0. This is the point P. So that's what they're saying. They're saying express the distance from P, P is xy, to the origin. So they want this distance right here. The distance from the point P, which they said is xy, to the origin 0, 0. So that formula represents the distance between 0, 0 and xy. All right, so now they're going to later, part B and C, further down the line, they're going to say, okay, But you need to get it only in terms of x. Oh yeah, in fact, they even said it right here, didn't they? I don't need to go far down the line. As a function of x. That means they don't want y. They just want x over there. As a function of x. So how do I make this only have x? What do I do with that y? What do I do?
Subtract square root of y squared.
Right here, it says y is equal to, and maybe replaced with, x squared minus 3. Right? Y equals x squared minus 3. So plug that in right there for y. Is that making sense, what I'm doing? So plug that in right there. X squared plus x squared minus 3 squared. See what happened there? So now it's a function of x. It's only x. Because that's what it means. If you're on this curve, this is the curve y equals x squared minus 3. So if you're on that curve, if you're the point xy on that curve, that means your y value is equal to your x value squared minus 3. That's the relationship between x and y for any point on that curve. Right? That's what an equation is a relationship between the x values and the y values on the curve. Right? All right, so now we just clean this up. This is x squared. You got to FOIL this out, right? X squared minus 3, x squared minus 3. I'm running out of room. So we got to do that whole thing. So let's do that. Where was I? I was at square root of x squared plus y squared, which was x squared minus 3, x squared minus 3. So FOIL that out. X squared plus, zoom, 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 x to the 4th, minus 3x squared, minus 3x squared, plus 9. Gather like terms, x to the 4th. X squared minus 6x squared is minus 5x squared. Is that okay? Did I do that too quick? See what I did there? I gathered like terms, right? It was 1x squared, minus 3 and minus 3. So it's really 1 minus 6. So it's negative 5x squared. So I just cleaned it up. There it is. There's that. That y, remember, is distance. That's distance. Yeah, I shouldn't say it's going to be y1 on my graphing calculator. I'm going to type it into the y1 slot. But it is distance. It represents distance. Remember, it all came from the distance function, right? That's what we started off with. It's just the cleaned up version of the distance function. We good to there? Is that making sense? Now, you guys have your graphing calculators? Let's type that into y1 and just graph it and find the minimum. Let's do that. Let's put that in. So let me go to a new screen. So y1 equals, all right, so y1 equals the square root of x to the 4th minus 5x squared plus 9. Right, okay, so I graphed it on my graphing calculator. I got, oh yeah, I gotta go back to the thing, huh? Thanks. I got this kind of a graph. What did it do? It went, oh, I'm not doing that very well. Like this, huh? I found this point, minimum, on the graphing calculator, and it came out to be, what did it come out to be? 1.58, comma, 1.66. All right, so let's talk about what that is and what that is not now. This is x distance. It's not y. Why? How do I know? Because this function was the distance function. Remember the y value that we just graphed, y1 was a distance function, remember? So this point I'm getting, or any point you get on that graph, is x distance. Because it's y, but it's y1 really. And what was y1? Distance. So if they ask you for an x value, you can tell 1.58. If they ask you the distance that point is from the origin, that's the 1.66. And if they actually want to know the y value on the graph, you've got to plug into the original equation. I'm probably totally confusing you right now because there's two graphs going on. Let me clear up your thinking, see if I can. So remember, the original graph was this. Are you getting confused between the original and the calculator graph? The original graph, this was the x squared minus 3 graph, right? And this, well then what's this thing? This is a distance graph. This is a distance graph from the calculator, from the graphing calculator, right? Meaning what? This is distance and x. So it's this point is the lowest distance. Its x value is 1.58, which is right here. This is the point at an x value 1.58 that has the smallest distance, closest distance to the origin. Smallest distance, minimum distance. So he's 1.58, but I don't know what, that's his x. I don't know what his y value is on the original graph. The y value on the graphing calculator, distance graph is 1.66, but that's a distance. Everybody see what's going on? See how we got two graphs really going on? The original graph, and then the graphing calculator distance graph. So just keep in mind, this is a distance graph. Y1 was distance formula, right? So well, then how do you find the actual y value on the original, where the point right here is at a distance of 1.66 from the origin. Is that making sense? That point at x value 1.58 on the original y equals x squared minus 3 graph is a distance from the origin of 1.66. That's how far it is from the origin. But what's his actual y value? Well, just plug that x into the equation. What equation? X squared minus 3, right? So you can just plug in the 1.58 to that, and then you would find, they're not even asking for the y value on this one, but they will on other ones. So I'm just letting you know. You would just plug into the original function, the x. But don't confuse y with distance. That's what everybody, not everybody, that's what a lot of people do. Is that making sense? So we have the original graph, where we were looking for the point closest to the origin. To find it, we typed in a distance function and graphed a distance function on our calculator. We found the minimum distance at the x value 1.58. That means that's the x value on the original graph, but the y was actually distance on the distance graph. That's the distance that point is. To find the y, you plug into the original, plug that x, 1.58, into the original x squared minus 3 function. So that's what they want. We found the point closest to the origin on the original graph, x squared minus 3. Questions on that? It's a long one, 25-minute problem. And number 2, which is going to be very, very similar. So here we go. So let me let you start that one. So give it a try. It's just like the last one. Let me let you do the first couple of steps. You'll get more out of it that way. So the function this time is y is the root of x instead of x squared minus 3. And instead of the origin and some point xy, it's 2, 0 and some point xy. Does that make sense? So just write the distance. So start by writing. You don't need to graph it. That was all just not required. Just go ahead and write the distance function right away. The 2 points are xy and 2, 0. Instead of they're not using the origin this time. They want us to find the point closest to 2, 0 instead of the point closest to the origin. So we plug in. Like so. Good so far? And if you had the order reversed, it doesn't matter. Remember, the order doesn't matter. Foil those out. You've got to foil those out. And then you can't leave y. So see if you remember what to do about the y. Got to make it all x in the end, huh? No y's. No y's allowed.
Do we foil it before putting in the y?
Well, y minus 0 is just y, huh?
Oh, yeah.
So there's no need to really foil that one. That's
So
just
you
y
have to
squared.
put- okay.
Yeah. So this is going to be x minus 2, x minus 2. This one's just y squared, right? Y minus 0 is just y. So FOIL. Like so. Bless you. And then we get x squared minus 4x plus 4 plus, and then what do we put in for y squared? Yeah, we plug in the original equation as given to us. Right there, y equals the root of x. Plug that in right there. So root of x squared, which is just going to be x. Everybody seeing that okay? So I'll let you, so clean that up. See if you can gather like terms. Get that cleaned up. All right, guys, what do we get here? X squared minus 4x plus 4 plus plain x, huh? X squared minus 4x plus x, it'd be what? Minus 3x plus 4. There we go. We good to there? So square root of x squared minus 3x plus 4. Getting that okay? Things I can answer up to that point?
Now would that be your distance?
Yeah, now type that into your calculator into y1. Exactly. So put that into y1 now.
But would that be your answer for that right there?
Oh yeah, right. That's the answer to part A. You're right.
Okay.
You're right. Good question. Yeah, part A they want you to actually that would be the answer to part A, and then part B they're going to say find the point that's closest. Yeah. So this is the answer to part A. Then in part B they'll say find the point closest. So you need to type that into y1. So let's just go on. Type this into y1 your graphing calculator. Go ahead and graph it and find the minimum. That's what closest means, huh? Minimum distance. So do that, minimize that function. Give you a second on that. So did you guys enter that in your calculator and get an answer? Let me see. I'll put it up here. Y1 equals, okay, square root of x squared minus 3x plus 4?
Yes.
Is that what it is? Okay, yeah. All right, so you type it into your calculator. You get some kind of picture, right, on the calculator. And then you find the minimum. And what did you guys get for the minimum? The x value was 1.5. Oh, straight on, 1.50. And what was the y? 1.3. And that was the distance, actually, right? The distance on that. And then if they wanted the actual y value of the point, you could plug into the original function. What was the original function? Oh, square root of x, huh? The original function. So this is x and distance. And then if you really wanted x and y, you would plug in the y value equals square root of x is the square root of 1.5, whatever that is. And we got it. Is that good? Questions on that?
Would we be able to leave square root of 1.5 as an answer? Or would we actually have to?
I think Math Excel will ask you for a couple of decimal places or something, so they want you to type it in. I'm fine on a test with square root of 1.5. Good on that? Is that making sense? If you have any trouble with the graphing calculator, feel free to grab me after class, or I sent YouTubes, I think, didn't I? Finding minimums, all that stuff, but grab me or try to find those, or you can search on YouTube yourself. I think I sent y'all to your emails, right? Some helpful YouTubes on all that. But they're very similar, even though they are a bit unique. Okay, so this one is like making a triangle thing. It's saying all those words, blah, blah, blah. We have y equals x to the 7th. That's the kind of snake graph they have there. It's a fancy, higher-powered snake graph. And they're basically saying, hey, wherever you stop, make a triangle. What's the area of that triangle? And they're going to say, what's the area of that triangle? So do you get the idea? They're basically saying, look, you got this snake graph thing. And wherever you stop, go straight over and straight down and make a triangle out of that. Well, I didn't do that very well. Let me try that again. They're saying wherever you stop along that snake graph, go straight over and straight down. Like say you stop here. Go straight over, straight down, make a triangle. What's the area of that triangle? So every stopping point will have a triangle. If you want one further up, you go straight over, straight down, diagonal, make a triangle. Right? And they're going to basically, in the end, they're going to ask us, how do you make what point will result in the biggest triangle? That's what they're going to ask us in a minute. Do you see how different stopping points would make different? I bet if I did it in two different colors, you could see it better. Let me try one more time. Because you might think, well, doesn't it just get bigger and bigger? It doesn't, because it gets narrower, right? It gets taller but narrower. So where's the best one? It's like if you stop here, for example, go straight over, straight down, do the diagonal. There's the triangle you get, okay? Now what if you think, well, just go higher up? Is higher always better? To a point, but not all the way. What if I go right here? Straight over, straight down, diagonal. See the area of that triangle? Is it more or less? It might be a little more. I don't know. It's hard to tell because it's a little narrower, but it's taller. So, yeah. Well, no, it's not. It's not narrower. You got to call me when I say wrong things like that. Right? It would only be narrower if this snake was coming back. Right? This snake's going out. I mean, not very fast, but it is going right. It's not going left. If it went left, it wouldn't be a function. It failed the vertical line test. Right? It's going up and right, so they are getting wider. The bases are getting wider, and it is getting taller. So I'm wrong. Let's just reverse all that I just said. Those triangles are getting bigger, right? Because as you go out, it's getting wider and it's getting taller. The base is growing and the thing's getting taller. And what's the area of a triangle? Half base times height, right? So the base is getting bigger, the height is getting bigger. Those triangles are getting bigger. So what are they going to ask me? I'm confused, to tell you the truth. Anyway, let's do part one and we'll see. All right.
What's everything showing?
Is everything? Oh, yeah. So what do they want? Oh, all they want's the area. Express the area. Okay, yeah, so I guess that's it. No wonder. You can't find it. It just gets bigger and bigger as it goes up. That explains my confusion. There is no final question because there is no maximum. It just gets bigger as you go up. The triangles get bigger. All right, let's just find the area formula. All right, so how do you find it? You need the base and you need the height. Let me erase this. So how do we find the base and the height of the triangle? Let's just use the one they gave us. So the base, I'll just call this the base and this the height. It doesn't matter which side's which. One side's base, one side's height. Okay. And what is that base right here? How do you know how far that is? What is the base? What is it? Which is? X. The base is X. Exactly. Does everybody see that? The base is just how far over you go. Right? The X value, to that point, to the point XY. This is XY, which means that point is over X, up Y. That's what it means to be a point on a graph, huh? Right? It's over X, up Y. Right? Everybody really clear? Let me draw that again. It's really, if you can get that start getting that really clear in your mind right now, that'll be really helpful because if you go on, you're going on into the calculus world. I just spent, I think it was 3 hours at the kitchen table yesterday afternoon with my middle child, my daughter, and she's taking Calc 2 from Mr. Dorn right now. She has a test tomorrow. So we were doing these, they rotate cylinders to fill up volumes, and they had all these tricky little things, and I kept saying, Lizzie, it's all about what does it mean to be X? What does it mean to be X? I must have said that to her 1,000 times. It means from the origin over, from the origin over. Just be clear on that on a graph. That's what it means to be an X value on any graph, right? It means how far over from the origin. So if you're just really clear on that, that'll help you in a lot of situations. That tells you this base here, doesn't it? Right? That is the width, because that's what X means. It means from the origin over to the point on the graph that you're calling XY. Right? And then and the height here is Y, isn't it? It's how far up. It's how far up to the point XY from the axis, or the origin, same thing. Am I confusing you by changing that? In other words, from the origin, it's over X, up Y, isn't it? To get to the point XY. So therefore, the base is X, the height is Y. So the base is X, the height is Y. Does that make sense on that one? Now, we can't leave it this way. We can never leave Y because they say as a function of X. As a function of X. So what do I do with that? How do I make that thing all X? Same thing we did before, huh? Just plug in the function, yeah. Yeah, just come up here to the function, just grab it, and plug it in. It's X to the 7th, so it's 1/2 X, X to the 7th. Is that good like that? Now Y becomes X to the 7th. On that. All right, so that's 1/2 X to the 8th, and we are done. Is that good? Questions on that? And sure enough, that bigger X is, the bigger that area is going to be. Huh? That's the area function. So we can tell what we were saying is true. The bigger the X is, the bigger that area is going to be. It does continue to grow. No questions? We good? We happy? Let's see. All right, so rectangle has one corner in the quadrant. Y equals 4 minus x. So this graph here is y equals 4 minus x squared. It's upside down U shape, right? Negative x squared moved up 4, right? Because that's really negative x squared plus 4. That's the same as 4 minus x squared, right? So it's the negative U, the upside down U shape moved up 4, right? You know all that. They're taking a point on the corner, xy, and they're saying, hey, go straight down and straight over and make a rectangle. And what's the area of that rectangle going to be? Basically what they're doing. This one they will ask us to find minimum or maximum or something in a minute. So first off, can we find a formula for the area of that rectangle? Let me give you a second on that. So find the area of that rectangle. So always start off with the basic formula for the shape. Last one was triangle, half base times height, right? So, and then do the XY stuff after that. So just start off on this one. What's the area of a rectangle?
Base times height.
Yeah, call it base times height or length times width or whatever you want to call it. It's the two sides, huh? Yeah, base and height is good since we've been using that. Length and width is fine. Doesn't matter what you call them. It's just one side times the other. Don't need the half, right? The half for a triangle, because if you have a rectangle, half of it's a triangle. That's why we have the half in the triangle formula, right? Okay, so we have base times height. So what's the base and what's the height? This is the base. This is the height. And what are they? They're x and y again, aren't they? Right? Because that's what xy means, again, on a graph. From the origin, xy means how far over and how far up from the origin to that point, huh? So x and y are the base and height again, yet again. So the base is just x, the height is just y. That's the area formula. Why am I not done right there? I'm almost done. Yeah, I got to make it all x, huh? So how do we make it all x? Plug it in again. These are getting easy for you now, right? Is that good? Like that? And then they probably want you to distribute. So 4x minus x cubed. There we go. And we've got it. Questions I can answer on that one? Oh, they're going to actually want more from us. Yeah, let's go on. They're going to, so that's the area formula. Let's go see what parts 2 and 3 are here. I'm just saying, if you pick a value like x is 1, just randomly picking a value like x is 1, and you plug it into the original function, it's the point over 1 up 3. Right? That's the point over 1 up 3. Right there. Right here. Over 1 up 3. And then you make a rectangle by going straight down and straight over. You make that rectangle. It's going to be a 1 by 3 rectangle. The area is 3 times 1, 3. Is that what this formula would have predicted? Put in a 1. The area formula says, I can tell you it without doing all that drawing. Just plug your 1 into me. Plug a 1 there, plug a 1 there. What do you get? 4 minus 1, 3. Do you see what that formula is doing? It's saying, you plug your x into me, boom, I'll give you the area of the rectangle formed underneath me. So you see, it isn't like it has to be squared or something just because that's a square.
It's not like a dimensional.
It's not a dimensional thing. It's the formula that tells you the area of the rectangle underneath on any point on that curve.
Just changes the number.
Yeah, it could change for, with different kinds of curves over a rectangle.
Right.
See what that thing's doing? It worked in that case, didn't it? It's giving us the area of the rectangle underneath it. Yeah, so then they, so I guess they just do domain and range and. Oh, okay, good. Let's do that then. So they do ask for largest. So let's go ahead and type that into your graphing calculator there. Put that into Y1 and hit maximum. We're trying to find the point that will make the biggest rectangle. Make sense? As the curve goes down and you make rectangles, you get wider ones, but they're shorter. As it goes high, you get taller ones, but they're more narrow. So there is a give and a take on this one. It's not just bigger, 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 right? Part gets bigger, part gets smaller. It gets shorter but wider, or taller but thinner. So where's the best? Probably right in the middle. Probably right in the middle is the best. So maximize that thing. So let's do that. So we want to take y1 equals, what was it, 4x minus x cubed? Mm-hmm. And graph, find the max on the graph. So what do you guys got? Anybody got it? Maximum. 1.15, anybody else getting that?
Yes.
Yeah, good. And that's x and distance, no, not distance, area. In this case, yeah, it's an area function. You guys understanding the y value is the function you tell me, what is this? This y is area now, isn't it? It's not distance, but area of the rectangle underneath. So this is distance area. What did the area come out to be?
3.08.
3.08. So that one we did a minute ago where we got area 3, that was almost as big as it got. This one's a little bigger, area 3.08. This is the maximum area rectangle you can form underneath from a point on the curve 4 minus x squared. Yeah. So there it is. Make sense on that? We good with these? Okay. So here we have it. Area as a function of x. So now we're taking a circle. We're taking, and we're inscribing a rectangle inside of a circle. Does that make sense? So you're putting a rectangle so that it barely hits the 4 corners on a circle. And in the end, they're gonna ask us, what's the biggest rectangle you can fit inside of that circle? That's gonna be their final question to us. So you want to put a rectangle inside of a circle. How can you fit the biggest rectangle in that circle? That's their question. What do you think? Anybody have a hunch as you look at it? What's going to be the biggest rectangle you can fit inside that circle? It's going to be a square. It's going to be the one that's the same length that it is width. Am I making any sense? Right? If you have a circle, there's different. That wasn't a very good circle, but good enough. There's different kinds of rectangles. You could fit a rectangle in like this. That's kind of wide and short, right? That hits 4 corners. That's an inscribed rectangle. You could do one that's kind of tall and narrow. That's a rectangle that hits the 4 corners. But what's the one that holds the most area inside? It's going to be the one that's got the same length and width, isn't it? See how that one, the square, same length and same width, is going to hold more area than the tall, thin ones or the short, wide ones, right? It's going to be a square. Now, we'll find that mathematically. I'm just telling you in advance that is the answer. Let's go and actually find it now. So we begin by writing an area function. So go ahead, write an area function for the area of that rectangle. So what do you start with? It's a rectangle. So what's the area formula for any rectangle? Length times width, right? Or base times height. Or I guess we've been calling it base and height, so I'll go back to that. Base and height, whatever you want to call it.
Same thing, right?
But yeah, totally the same. They're just names. Call them Joe and Tom. They're just names. One side, other side, whatever you want to call them, right? So you got the 2 sides, base and height, length and width, whatever. So let me let you do this. This trips people up, and there's a problem like this in Calc 1. So give this a try. Write the base. Notice this is the point in the upper right-hand corner. This is the point x, y. Remember what x means? From the origin, over x, up y. That's what I kept saying to my Lizzie girl yesterday. From the origin. So what does that mean? What's the base? The base is that, clearly. So what's the formula for base? What is it? What's the base? It's always funny to me how hard this is. I mean, it was hard for me too. I'm not mocking you guys. I'm mocking my daughter. I remember when I first took this stuff, it seemed so confusing. But I think you'll see it's easy once I show it to you. Remember, from the origin, just remember, what is x, y on a graph? It's funny how we just forget that or we're not crystal clear on that. From here, over, as soon as I draw this, you'll be like, oh, that's x, isn't it? And then up is y. That's what x, y mean. To the point, x, y. That's the point x, y, the graph says. Right? This is the point x, y. That means from the origin, over x, up y. Right? So then what's the base?
2x.
2x. Clear as day. Right? That's what the base is. I'm telling you, that's on a Calc 1 test. It was on my Lizzie Girls Calc 1 test last year. And all she did was forget the 2, and she got a 0 on that test, I remember. I'm telling my daughter's life here. So she'll appreciate that. I'll play this back for her later. Yeah?
So why wouldn't it be x squared?
So what is x? X is how far from here to there. That's what x is. That's what it means to be. If you have any graph, think about what it means, guys. If I say this is the point xy on anything, what does that mean? That means from the origin, over is x and up is y. That's what it means. That's what coordinates xy mean, huh? From the origin over and up. Well, look at this graph. Look at this graph with me. Right? From the origin, which is right here, over x. Isn't that what x means? Because this point here is xy. That corner, they're telling me that.
Double.
So, and this is y. So the base is all the way across here. So it's double x. It's not x times x. Maybe it's not x. That'd be x squared. It's x times x. It's not that, right? It's double x. And what is the height? It's double y, right? The height is double y. So you can just put those together. That's 4xy. Those are just all multiplied. You can reorder them. 2 times 2 is 4. So that's 4xy. The area formula is 4. We got to plug in the y now. But does that make sense on that? So now, what is the, did they give me a formula? Because I get to plug in, right? I can't ever leave the y. I got to plug in. So where's the formula? Right here, huh? X squared plus y squared is 16. So you got to solve that thing for y and plug it in. Does that make sense? Take this. X squared plus y squared is 16. Solve for y. Jump the 16 over. Negative x squared plus 16. Or you can put 16 in the front, whatever. Square root it. So y is the square root of negative x squared plus 16. Plug that in right there. So area is 4x square root of negative 16 plus x squared. There it is. Can you read that? I'm being a little scribbly there. Let me clean that up. Let me get rid of this graph over here. So okay, you guys okay with that? Can we do this again?
Yeah.
One more time. So I just took the little formula and I solved for y. That's all I did. So I just took x squared plus y squared is 16. I thought I got to get y alone because I got to plug into here. Question?
Yes. So when you're answering, how you put 16 and x squared?
Uh-huh.
Like how it's squared? Could that be simplified?
No, yeah, good question. Really good question. You can't. Let me talk about that. I'm glad you asked that. So I'll put the x squared in the back this time. So everybody see what I'm doing? I'm just subtracting x squared from both sides. And then I just root both sides, and that cancels that out. So that makes it plain y, doesn't it? Everybody see? Yeah, now plug that in right there. So the area becomes 4x, and the y is square root of 16 minus x squared, or negative x squared plus 16. Same thing. Now, really good question. Can you root that 16 and make it 4, and root that x squared and make it x? You cannot, because of the plus and the minus. Really good, really important point to know, and that trips up a lot of people, especially as you move into calculus. Square root, when you got pluses and minuses, you can't do that. It's because of the plus and minus. You can prove it with just numbers. So what I would do, again, I'm showing you to test with numbers. If I looked at that and I was in the middle of the test and I thought, ooh, can I do that? I would go, well, let me try. What if it was 16 minus 9? Is that the same as 4 minus 3? Because that's what it would mean, right? To root the 16 would be 4, to root the 9 would be 3, which is 1. Is that true?
No.
This is the root of 7. That's not 1. Not true. Right? Everybody see that? And is the problem really the plus or minus? It sure is. If that was 16 times 9, it would just be 4 times 3, which is 12. Really? What's 9 times 16? 144. What's the root of 144? Sure enough. The problem is the plus or minus. It's good if you can put in the back of your mind, pluses and minuses wreck algebra. That's algebra, but it's fancy algebra, right? That's what you're doing. Yeah, as you move forward into calculus, it's all those little algebra rules that you really need to get down. One big helper is to know pluses and minuses make everything hard. Basically, if you're ever wanting to do something nice, like that would be nice if we could just root the 16 and root the x, right? That'd be very clean, not with a plus or minus. Nothing nice ever happens with a plus or minus. That's pretty much almost always true in algebra. That was times in the middle, sure, but not for plus. But they glue things together. That's what they do. You know what? I always make and when I teach algebra, it's such a theme. I make the Costco analogy, right? You ever shop at Costco or Sam's Club, right? You go there. I got 5 kids, so my wife shops in bulk, right? They sell in bulk there. So you go to grab one spaghetti sauce or one milk. You pull it out. It's plasticed to another one, or 4 of them, or whatever, right? You can't bring your scissors to Costco and cut that. Say, thanks, I just want one. No, you can't. That's the whole point, right? Well, that's what pluses and minuses are like in algebra. They glue things together. Plus and minuses glue them together, make them a package deal, which means you can't do anything nice. They're always stuck together. You can't ever just like root the parts or do nice things. It never works. The pluses and minuses glue things together throughout the rules of algebra. So good question. Thanks for asking. That's an important point. All right. So we got our area formula. There it is. Plug that into your calculator. Can I just say the rest is the same for here? Plug it into your calculator, graph it, find the maximum, and it'll turn out. Is that good? Yeah.
If it's
Right. Yeah, good question. Yeah, why is it I don't do the minus? Oh, yeah. Yeah, good question. Yeah, when I rooted both sides here, technically I'm supposed to put plus or minus, right? When you root both sides, you're supposed to put plus or minus. That's a good question. That's true. In general, that is true. I'm using this, that y is plus or minus, root of 16 minus x squared. That is true. But I am representing height. What if I said, how high is that? -3. Height is never negative, right? So whenever you're doing math, keep one foot in math, keep one foot in reality. So the height cannot be a negative number, so I'm not going to, so that's why we skip the negative option. Good question on that. So that'd be just like, you know what I mean, like if you're doing a triangle, Pythagorean theorem, and you say, okay, this is, what is this, 5, and this is 4, what is x, you know, well, x squared plus 4 squared is 5 squared. If you work it out, in the end, you'll get x squared is 9. When you root it, x can be plus or minus 3, but could it really be -3 if it's a triangle? You throw away the negative, right? So lots of times in math, right? Math doesn't know the world we live in. I'm getting pretty philosophical today. But you guys are asking good questions. Math is not real, right? I've talked about that, haven't I? Have I talked about that? I don't want to go too long, because we got other things to do. But real quick, math is not real, right? It's made up to describe things that are real, right? You can't taste, touch, or smell 3. I've talked about that, have I not? Right? 3's not real, right? 3's just made up. It's my head, your head, but we use it to describe things that are real. If I see 3 cars had a car accident out at McKinley and Blackstone, I come and tell you it's not 3 cars. You know 3-ness, I know 3-ness. We can talk about things that are real. But math itself is not real. So when we do roots and get plus or minus and stuff like that, math doesn't know. We don't live in a world where something can't be -3 wide. If we lived in some world with extra dimensions where you could have negative widths, then great. Math's just running the numbers, saying, hey, them numbers work. Those numbers work. That's all math is doing. But we have to keep in reality. All right, it's probably more answer than you needed. All right, let's go on. Clock. It's the story of my life. All right, let's go there. All right, let's wrap this one up. This one's kind of weird. I was hoping to have a little more time on it. They're basically going to take this big piece of cardboard. They're going to cut out 4 squares from the corners, and they're going to fold it up to make a box that has no top. Okay, so it's they want us to do it in the way that will produce the biggest volume. Make the box that'll hold the most. Very practical problem for UPS, FedEx, shipping people, right? They can get a little more space out of the same amount of cardboard, save 50 cents on every box. What do those companies ship? I mean, Amazon's taking over the world, right? And the people that serve them, UPS and FedEx, are right along with them. They serve, I don't know how many millions of boxes a day. They can save 50 cents a box by shaping it up better. That's a lot of money. So what is the way to take that flat piece of cardboard, cut out the corners, and make it into a box to hold the most volume? How much should we cut out from the corners to make the box that'll hold the most volume? Again, no top. That's a other issue, you know, but just forget about the top problem. That just gets too complex, basically. So we just want to say, hey, a box that holds the most by cutting out the corners. How do we do it? Well, we need a volume formula for a 3-dimensional box. Did you know volume of a 3-dimensional box is just length, width, height? You know? If you have let me just draw a little 3D box thing. It's just width, length, and height back here. right? For a three-dimensional box, the volume is length, width, height. Okay, so what are the length and the width and the height of the box we're going to form? Well, can you tell that the width is going to be this piece right here? Right, that's going to become the width of the box after we cut out the corners and fold them up. Does everybody see what's happening there? We're cutting out the four corners, the x by x, x by x, x by x, x by x, four corners, and we're going to fold up the box to be like that with no top, right? So that's going to be the width of the box over there, isn't it? That's going to become the width here, isn't it? And the length here is going to become the length here, and then the height is hard to see. We'll do that in a minute. So everybody see that? So that inner piece is going to become the length and width. That's going to become the new base, isn't it? Right? Everybody seeing what's happening there? So that inside square is going to become the new bottom. It's going to become the new base over here, isn't it? So what is that width? Well, all the way is, what's that number? 18? 18. And we're folding up x, and we're folding up x. So what's the width? 18 minus 2x. Does everybody see that? Because it's 18 originally all the way across, but we're x and x we're folding up. So we're losing x and x. So the width, the middle part, is the whole 18. Take away the two corners, take away the two x's. Right? And the length is the same thing. Because the length is the whole length. Take away this part, which is x and x. So it's 18, right? Because the whole thing, again, is 18. It's a square originally. Minus 2x. So the length is 18 minus 2x. The width is 18 minus 2x. Good so far. Now we just need the height. Am I going too quick? Is that making sense? Let me show that again over here. Right? So again, it's 18 all the way. This is the length. And this is x. And this is x. So the length is 18 minus 2x. So is the width. All right, what's the height? Good. Everybody see that? It's just x. Because that's what's going to fold up and become height, right? See that little x piece? It's going to fold up and become the height of the box, isn't it? X, just straight x, is going to become the height. Okay, so there's our volume formula. Really, you could just type that into your calculator. You don't have to FOIL it all out. Your calculator can handle that straight. Math Excel probably won't be happy, though. They probably want you to FOIL, so I better FOIL. What's 18 times 18? 324. I think I did it yesterday with the other class. Minus 36x minus 36x plus 4x squared. And the other x is just sitting out there. And so 324 minus 72x plus 4x squared. The x is sitting out there. Boom, boom, boom. Distribute. And you get 324x minus 72x squared plus 4x cubed. There's the volume formula. Everybody good with what I did there? I just FOILed out the 18 minus 2x, 18 minus 2x. Left the x sitting on the right. Got my answer. Distributed the x. So there's our volume formula. Now the rest is the same. Just type that into your calculator, graph it, find the maximum, then you'll find the box of maximum volume. We good with that? Can I go to review? We okay with all that?
So is this the answer then?
Okay, so I'm going to go through these rather quickly then. I was thinking I had a little more time until I realized what time we're done. All right, so we're going to start with y equals the absolute value of x. They're going to tell us to do a few things. Shift it right 3 units. What takes in an equation and shifts it right 3 units? Do you remember? Minus 3 in the absolute values. right? Not like this, not outside. Why would the minus 3 out there, or plus 3 or whatever, not be right? Why would you not put the 3 outside the absolute value? Then it would be an up-down thing. It would be a y thing, right? Only things in there with x make a right-left effect. Remember that? In the parentheses, in the absolute value, in the root, in the whatever x is in, for right-left. So that's going to make it go right. And x does the opposite. That's why negative is actually right and positive is actually left. Because x does the opposite, doesn't it? So that's a right 3. Next, stretch vertically by a factor of 3. Vertically. Is that an x or a y thing? Vertically. It's an up-down thing, right? So that's a vertical thing, that's a y thing. So am I going to put it inside the absolute values or outside? Outside, because it's a y thing, right? So the 3 is going to go, and it's multiplied. It's not added or subtracted. Added and subtracted things move the graph. Multiplied things stretch it and compress it. And we're talking about a stretch. Does that make sense? So that's a vertical stretch times 3. All right, next one. Down to. Now we're moving it. Down to. Down to is a y thing. So is that going to go inside the absolute values or out? Out. So that's going to go out, down to. And y is just normal. Negative is down, positive is up, right? Y is just normal. All right, good there. Now comes the trick one. Finally, reflect across the x-axis. Here's the x-axis. They mean the x-axis is like a mirror, and you're reflecting things across the mirror. Across the x-axis. So if you reflect something across the mirror, if the x-axis is acting like a mirror, then it's an up-down kind of reflection, actually, isn't it? It's a vertical thing. So whatever I'm going to do has to do with y, actually, not x. Even though they said x-axis, the x-axis is the mirror. So it's reflecting across the x-axis. It's a y kind of thing. So what do I do then? What's reflection do? Change the sign, -1 on it, right? So who do I put the -1 on, x or y? Y, because it's a y kind of thing, right? It's an up-down thing. So I do like that. Now that's weird. I've never really shown you that way before, but I think that'll be a little easier for you to think about. That's correct. I still got to do something to it to make it match one of these guys. But if you just gave me this answer on a test, that's fine, unless I give you multiple choice. You got to find which of those it matches up with. So far so good. I made y -1. -1 times y is -y. Because it's a y reflection, isn't it? It's an up-down reflection. Now, I've got to make, all these have positive y. So to make it match one of those answers, I've got to get rid of that negative on the y. What's going to get rid of that negative on the y? Multiply both sides by -1, huh? That's positive y, -1 times the whole side. Now, you could distribute it on the right there, but they didn't. That shows me it's answer C. It's okay to distribute it. It's not wrong, but I'm just trying to make it look like one of those answers. Answer C, it matches up with perfectly. So it's answer C. Everybody good with that? Okay, let's try it.
You said it was C then, right?
Answer was C, yeah. Yeah, all the answers are on the practice exams at the back. All right, so what do you do? Now, this is a piecewise. There'll be one piecewise for sure on the exam Thursday. So what do you do on a piecewise? Well, you got to put the walls in. See, it's in different pieces. It's this function in this zone, it's that function in this zone, and this function in that zone. Right? It's different functions in different zones, isn't it? So you gotta put that on the graph. So how do you do that? Well, use the walls. What does it say? -8 and +4. So I would go over to -8 and put a wall. That's at -8. And I would go over to +4 and put another wall. -8 and +4. Good so far? Now, put the correct functions in the correct zones. What do I mean? X plus 3 is supposed to be the function that's in charge when x is between -8 and 4. So that means here in the middle, huh? X plus 3. I'm going to graph x plus 3 in the middle. That's what it's telling me. Now over on the right, when x is greater than 4, I'm skipping the equals 4, I'll come back to that. When you're on the right, x greater than 4, to the right of 4, you're supposed to use -x plus 7. So over here, I'm supposed to graph negative x plus 7, aren't I? And what do you do right on the 4 line? What does it say? When x is 4, y, f is just y, right? When x is 4, y is just straight negative 9, period. There's a dot there, huh? So let me just put that dot on the graph. Over 4 down 9, it's about right here. Whoops, can't do it. There we go. That's over 4 down 9. That's what it's telling me. When x is 4, y is negative 9. Good so far?
Do we have to label our coordinates to get the points for it? Like, do we need to be labeled?
Yeah. Show me the coordinates on there. So now, what is in this zone? I'm going to do this one. So now I'm going to suggest make a table for this region, and then make a table for that region. So when we make the table for the middle region, which x values am I going to plug in? I'm plugging in for this one now.
0.
You could do 0, but what I'm going to suggest is negative 8 and 4. We only need 2 dots, and you need to check the walls, so you might as well just do both the walls. 0 is okay. 1, 2, and 3 are okay, but definitely you want to do the walls, so let's just do the 2 walls. Negative 8 and positive 4. So here's the mistake I get all the time from students on this. Everybody hearing me? I'm not doing the Charlie Brown teacher wah-wah-wah for you right now, am I? Hear this. This is the mistake I always see students make. They'll go, wait a minute, mister, and that's x less than 4. Less than 4. You shouldn't do 4. You should just do 3. Because it's only less than 4 for that table. Less than 4, not 4. So you just stop at 3. It is less than 4. But there's a lot of things between 3 and 4. There's 3.999999999, basically 4. So that's why, remember, don't stop at 3. That's way short. Do 4 and circle it. Remember, that's what I suggest. Yes, it's not going to quite hit 4. You're right. It is x less than 4. But it's going to get so darn close that it might as well be 4. It's going to be 3.9999999. So it'll get to 4 with an open dot, won't it? So you need to really do 4, even though it's less than 4. Does that make sense? Okay, so I circle it, and I'll circle whatever y comes of it, because it's an open dot. So let's plug those in. Plug into what? Plug into x plus 3. Plug in negative 8 plus 3, that's negative 5. So that's negative 8, negative 5, right here. Solid dot, because that one equals 8, doesn't it? It's less than or equal, or greater than or equal to 8. So that one's a solid dot. The 4, plug in 4, you get 4 plus 3. Is that 7? Over 4 up 7. Where's that, right here? Oh, that's supposed to be open dot, huh? Let me try again. But right there, over 4 up 7, connect the dots. There's the graph in the middle. Straight line, I just connected them. Found the dots on the walls. Now what do we do over on the right side? Again, you got to plug in the wall, but circle it, because it says x greater than 4, but don't start at 5. Well, let's do 4 and 5 would be good. 4 and any other number would be fine. Just you need 2 dots. So I'm going to do 4, but I'm going to circle 4. Plug into y equals negative x plus 7. So plug in, what's the thing for it? It's 3. So over 4 up 3, it's about right there, open dot. And plug in 5. Negative 5 plus 7, 2. Over 5 up 2, it's about right there. Over 5 up 2. Oops, kind of scribbling now. Over 5 up 2, this is over 4 up 3. Connect the dots. We're done. So we did the middle section. We did the solid dot right here. 4, negative 9, and then the open down it goes. We good on that? So you're graphing different graphs in different sections. So it's important to put those walls in there and write up in the top which equations go for which sections of the graph.
Just put in line. But that one would be solid.
Okay, so on this one, how are we doing? 20 minutes, all right. We've got y equals negative x plus 2 cubed. This is not piecewise. This one's not in pieces, right? It's just one function. So remember how I suggested you graph these. Central point and one other point. So make an xy table. I'm going to find the center point and one other point. How do I find the center point? Zero out the x zone. Right? Plug in the x. Plug in x to zero out the x zone. What am I talking about? This right here. So when I say the x zone, I mean what's in the parentheses, or what's in the absolute values, or what's in the square root, whatever little world x is in, make that zone, plug in whatever x will make that little zone become 0. So what x can I plug in there that'll make that become 0? Negative 2. Does that make sense? If I plug in negative 2 to that little world, I'll get negative 0 cubed, which is just 0. We good so far? What that means is, that means that's the center. Here, I can put it back in the main graph. That means back 2, up 0 right here, is the center. I'll just call that the center. That's the center of the graph. Normally, these original 6 graphs, right, which you're going to have in your 3x5 card, right, the absolute value and the square root and this x squared and all those, they're all centered at the origin originally, right in the middle, huh? But they're moved with these equations. So this one's moved. His new center is back 2, up 0. Okay, now, what do you do to find the one other point? All you need is 2 dots and the general knowledge of the shape. So how do you find the other dot? Add 1. Remember how we just always add 1 to whatever our first x value was in the center? Add 1. That would be negative 1, right? Negative 2 add 1 is negative 1. Plug that in to the equation. So y will equal negative 1 plus 2 cubed. What is that? Negative and 1 cubed. That's just negative 1, huh? So negative 1, it's right there. There's the other dot. So we have the center dot. We have the center dot. And we have one other dot. And what is this shape? Now we're ready to connect them up with the graph. What kind of graph is x to the 3rd power, which is what we have? It's the snake, right? So the center is going to go like this. Because here's the center, here's the other dot. Does that make sense? How I came up with that graph? The power graphs are bold turned up, bold turned down. They go up fast and down fast because they're powerful. X to the 3rd, x to the 2nd. They rise and fall quickly, don't they? Good on that one?
That's all you wanted for that?
That's all I want. All you need is the center point and one other point. That's all that's required, and then connect the shape. Let's try the second one. How about this one? Y equals the square root of negative x plus 2 minus 3. So give that a try, guys. Let me let you do that real quick. Find the center point and one other point. Right, so plug in for x whatever is going to zero out that little x zone, right? I'll let you do that for a minute. Okay, so what's going to zero out that x zone? Positive 2. Does everybody see that? Right, because you're plugging into negative x plus 2 with the minus 3 on the outside. So plug in the 2. Regular 2, right? Regular 2 because the negative's already there in the formula, huh? So you get root of 0 minus 3. You get minus 3? Is that good? Is that making sense? So that's going to be the center point. So let's put that on the graph. Over 2 down 3. Right there. Is that good to there? And now we need to find one other point. Normally, well, is that really okay to there? Questions I can answer? I'm going fast, I know, but please speak up if I can help. Normally we add 1 now, don't we? It's not going to work this time. This is the one time it doesn't work. And we're going to end up having to subtract 1 instead of adding 1. So when we add 1, we get 3, and 3 just won't work. I'm out of room here, so I'm going to come over here. If I try to plug 3 into this formula, I'm going to get minus 3 for the x, you know, plus 2 minus 3. That's the root of negative 1 minus 3. No. You can't have the root of negative 1. That's imaginary, huh? So that one's no. That means over. I'm going to put that on the graph. You don't have to. But over 3, no. Which means, here's the center, and over 3 is to the right of that, and it says no. That means it doesn't go to the right of that. That graph doesn't go to the right. Okay, so what does it do then? It goes left. So instead of adding one, when that doesn't work, which is very rare, it's just this one time, when adding one, you always start with the center point, whatever that may be, whatever zeroed out the x zone, and then you add one to find the other point. If it doesn't work, subtract one. So that'll be plugging in positive 1. If you plug in positive 1, what are you going to get? That'll be the square root of negative 1 plus 2 minus 3. Square root of 1 minus 3. It's at negative 2 over 1 down 2 right there. Is that good? I found the other point. Over 1 down 2. We good? Now we just need to connect them up with the shape. But that's easier said than done. I've seen a couple, let me show you a couple of the mistakes I've seen over the years so that you hopefully won't make them. Let's see, let me get straight what is true here first. Over 2, right. Okay, right. So what I've seen is I'll see this, for example. That's wrong. Why is that wrong? What's wrong about that? Yeah, there's the center point. So that's why I suggest you put a C next. See how this graph did not start from the center point, started from the other point? They mixed up which one was the center point. This one's the center point. The graph's going to go that way. Remember, it doesn't go to the right. It's going to start at the center and go towards the other one. So make sure you're starting with the center. That's why it's important that you know which one is the center and start from that one. So going back, so again, over 2 down 3, this one's the center. And the over 1 down 2, that's this. So start from the center. Start here. Okay, now here's the other mistake I see. People go, oh yeah, I got to start from the center, and they'll go like this. Why is that wrong? That started from the center and went left and went to the other point. Why is that wrong?
It's not the right graph.
Yeah, it's just not the right graph. It's bowl turned up, concave up. No. Square root graphs are slow growth functions, huh? They don't go up fast or down fast. They're mostly sideways. So you have to, and I'll give you some partial credit if you do that, because you still got the points right, head in the right general direction. But to get the full credit, you want to start at that center point and go like that. See how that's bowl turned down? No, I didn't draw it very well, but yeah, that's good enough. But that bowl is turned down. It's a slow growth. Remember the root functions, square root, cube root, same thing. They're all bowls turned down. They're all mostly sideways, whereas the power functions are mostly up and down. They're bowls turned up, right? Or down, for down. All right. Is that good? Questions? Get on to part 2. Okay. So remember how to go backwards? This is the go backwards ones. Like they give you the picture and they want the equation. How do you take like this piece of line there and find its equation? Yeah, mx plus b, find the slope, exactly. It's a line equation, so it's y equals mx plus b, right? M is the slope. Remember, slope is rise over run. Slope is rise over run. That's what m is. So then you look at this and you go, what's his rise? What's his run? What's his rise? What's his run? From one point, from the starting point to the other point, how much does he rise? 4. It looks like he goes up 4 and over, is it 3? Yeah, 3. Up 4, I've kind of written all over it now, but if you look back at the original graph, it's up 4 over 3. So it's rise over. So the m is 4/3. Up 4 over 3. Rise over run for slope. Okay, now what's the b at the back? What's the b part? How do you find that? Remember what that is? What's that? The intercept, exactly. Yeah, the b is your y-intercept. And that's it up 4, isn't it? So there's the equation. It's where it hits the y-axis. It's the y-intercept. We good there? So that's the equation of the left line segment. Now, what's the equation for the right line segment? How do we find this piece? Same thing. Y equals mx plus b. The slope is rise over run. It goes up 2 over 3. Up 2 over 3. So 2/3. What's the b? B is 0. Right? Because it hits right here on the y-axis at a height of 0, doesn't it? So the b is 0. All right. So to finish the question completely, you have to write these in their sections. What I mean is you have to say, all right, it's y equals or f of x equals. And then you're going to write like the I'll put the 2/3 x here, and the other one is the 4/3 x plus 4. And then you gotta, well, I'm running out of room, aren't I? Let me bring it down here. So y equals 4/3 x plus 4 and 2/3 x. But you gotta write where they exist. So where do they exist? Well, I've kind of made a mess. Let me go back and look at the graph. So the this graph, this first one here, exists between x values of -3 and 0. And the other graph exists, this graph exists between 0 and 3. Does that make sense how I did that? I looked on the x-axis for where those pieces of graph existed.
There's no one.
So this left one was between -3 and 0, and the right one was between 0 and 3. Now, as far as the equals bar, like I couldn't tell on the, if there was like an open dot somewhere, I couldn't even tell in the original. You can't even tell. I'm not going to hold you to anything. It wasn't clear to me if there was any open dots there. If there was, then you wouldn't have the equals bar, as you know. Does that make sense generally how to do that? So just find the two y equals mx plus b's, and then find the x zones that they're in, and write your function that way.
So to answer that correctly, is it y equals, or do we do the f of x?
I don't care. Yeah, both are
Doesn't
fine.
matter. Okay.
They're the same thing. All right, let's try that other part that was on that screen. Let's try this one. So I'll bring it up here. 1 minus 6 over 7x equals a half. How do you solve equations with fractions? Do you remember?
LCD,
LCD. Yeah, what's the LCD?
14.
And x plus
7x times 2, right? You take the two denominators and multiply them. 14x, huh?
sorry.
That good? 14x is the LCD. I just multiplied the denominators together, like that. And then what do you do with the LCD? You multiply every term, top, by the LCD. This is part one, so you won't have your graphing calculator, so you have to solve this by hand. So, I mean, you can use a normal calculator, but you'll still have to do the algebra. So 14x on through. The first one, 14x times 1 is just 14x. In the middle, it cancels. X cancels x. 7 goes into 14 2 times, and 2 times 6 is 12. Is that too quick? Remember that from algebra? You cross-cancel and multiply whatever's left over, right? The x's canceled. The 7 went into 14 2 times, and then the leftover 2 multiplied the leftover 6. So after you cross-cancel, multiply the leftovers. Over here, 2 goes into 14 7 times. Multiply the leftovers. 1 times 7 times x. 7x.
What does LCD stand for again?
Least common denominator. All right, now there's no more fractions. It's much easier. Let's solve it. I would subtract 14x from both sides. You could do the minus 7, and this is quicker. Minus 7x, last step is divide. So x is 12 sevenths on that one. Mr. Roberto is here. Do you want to say anything about hours or?
They're on there.
Oh, yeah. I don't think I even said that last time. Yeah, Roberto put his hours over there. So he's our class tutor, right? He's the ETC, Extending the Classroom Tutor. So he'll be available, what, today? No, today's Tuesday. Today's Tuesday. Tomorrow, 1 to 3. 1 to 3. We have our test Thursday in here. All right, so he's there 1 to 3. Get the help you need from him. All right, let's go on. So, all right, so do you remember how to do absolute value? So we have the absolute value less. Whoops. So we have the less, and then put a wall here, and here we're going to have the greater. And it's different, huh? Absolute value less versus absolute value greater. It makes a big difference how you remove the absolute value signs, whether it's less or greater. So this is what you definitely want to put in your 3x5 card. And I'm saying that for everything, I realize, but if you can, squeeze that in there. All right, so when you remove the absolute values with less, that's when you make the triple statement. Remember that? Like that, that's the triple one. Whereas for the greater, well, actually, first on this one, you're going to have to add the 2 to both sides. Because you always have to get the absolute values alone. So first, get the absolute values alone. And then remove them. Remember what happens when we remove them? In this case, this is where you get the 2x plus 9 less than negative 7, or 2x plus 9 greater than 7. And then you just solve. This one you solve. I won't do any more, because I want to look at something else real quick. But that's the most important step. You make it through there. Everybody's fine from there if you make it correctly through there. The direction of those symbols is really, really important. You know, I just want to be clear on what I'll give a lot of partial credit for and what I won't. You know, if you just add wrong or multiply numbers wrong, I'll give you a lot of credit. I mean, I might take off one. Sometimes I give full credit, even with the wrong answer, when you just added wrong in the last step. You know what you're doing. But where I don't give much partial credit would be like on this problem if you turn to one of those symbols. So I'm not trying to be harsh. I'm just trying to tell you ahead of time. You know, that really is important. Really important. You might think, well, I just got this one. That's the whole ball game, is that those are the right way. That really, really matters. That's the concept. That's the big idea. So make sure you really study this, which way these are going and how. The greater will always become a greater amount of equations, 2 of them, right? The less will be 1 triple, right? And that has to be that way. Absolute value less has to be a triple. Absolute value greater has to be 2 separate with an or. You have to do it that way. It's just not true other ways. And the symbols have to turn as they do there. Let's look at part 2 for just a moment. So do you remember the even-odd thing? So for even-odd test, what I said is 3 steps. Number 1, plug in negative x. Step 2, simplify. Step 3, compare. And I gave 3 cases. Case 1, it's the same. Well, let's just say the new. If the new equals the original, then that's even. I gave case 2. If the new equals negative 1 times the original, that's odd. And case 3 is neither. If it doesn't fit either one of case 2 or case 1 or case 2, then it's neither even nor odd. So that was the test I gave for evenness and oddness. Let's try it on this one. So first thing you do is take the x and you replace it with negative x. So I just took the x's and I plugged in negative x in both cases. And then I simplify. So simplify. So 2 negatives multiply to be positive. And absolute value of negative, that just vanishes because absolute values get rid of negatives, right? Is that good on the simplifying? Now, ask yourself, how does this compare to the original? Is it the same? Is it negative 1 times the original? Or is it neither of those? It's negative 1. See, the original has the negative on the 4x, and we don't. So it's negative times the original. So it's odd. This one's odd. Does that make sense? And the second one, number 5, cube root of, stick in a negative x for x. Get the cube root of, simplify. Simplify. That negative x squared is just going to vanish because negative squared. So how does this compare to the original? It's the same. So it's even. Does that make sense? Let me show you. All right, so 11 and 12. Remember, I gave a rule. It's not a function if you have y to some even power or plus or minus anywhere. Otherwise, it is a function. It's that simple. So easy. These will be free points if you have that in your 3x5 card or your mind. So you just look at that original up there. Number 11. You say, all right, does it have y squared or y to any even power? Yeah. Well, then it's no good. It's not a function. How about the second one? Does that have y squared anywhere? No. Does it have a plus or minus anywhere?
No.
Nope, then it's good. It's a function. That quick. Those are free points, right? We good? We did most of them. All right. Well, we'll stop there. Test on Thursday. Study hard, I hope.